So in this problem we want to take the antiderivative of x squared times e to the 3x, which will be an integration by parts. And what we know from exponentials is a lot of times we like those to be our dv, which is going to be the case here. And the x squared is going to be our u, so this is actually going to require integration by parts twice. So our u is going to be our x squared. Our dv is going to be an e to the 3x. That 3 isn't too big of an issue, it's just going to add some extra constants that we have to keep track of. For instance, our v, well, it is e to the 3x, but it's 1/3 e to the 3x. And the reason is because this is a chain rule. If we were taking the derivative, we'd have to multiply by 3. So the antiderivative, we have to divide by 3 or multiply by 1/3. Our du is 2x dx. So putting this together, we have our u and our v. So 1/3 x squared e to the 3x, the product of these two, minus the integral of v du. So 1/3 e to the 3x times 2x dx. I like to pull out all constants before I redo my integral. So 1/3 x cubed e to the 3x minus, I'm going to pull out the 2 and the 1/3, so minus 2/3 times the antiderivative of x e to the 3x. I'm just changing up the order of our product to match what we're used to seeing. You don't need to. So there's our other integration by parts, and we can see it's going to be a similar substitution. U is going to be x. Our dv is going to be e to the 3x dx, which makes, again, our v 1/3 e to the 3x. And this time our du is just a simple 1 dx, or just dx. So we have 1/3 x cubed e to the 3x minus 2/3. And now I'm going to do my integration by parts, but you got to be careful that minus 2/3 applies to everything I'm about to do, which is why I have this open this set of parentheses here. So u times v, so x times 1/3 e to the 3x minus the integral of v du. 1/3 e to the 3x dx. So let's clean this up a little bit. This part's already done. 1/3 x cubed e to the 3x. We'll take care of that minus 2/3 here shortly. Now we'll open these parentheses. I've got 1/3 x e to the 3x, and again I like pulling out constants, so minus 1/3 antiderivative of e to the 3x dx, which we've actually done twice already. So we should be able to do it one more time. We've done it here, and we've done it here. And this will end our antiderivative, and it's just a matter of bookkeeping or keeping to our constants. So that minus 2/3 is going to get applied to everything in these parentheses after we're done with our integration. This is minus 1/3, and we know the antiderivative of this guy is 1/3 e to the 3x. And that plus c, I'm just going to put at the end. It does not need to get multiplied by any of the constants because it's just an arbitrary constant. So we have 1/3 x cubed e to the 3x. That negative 2/3, when it gets multiplied here, is going to give us a negative 2/9 x e to the 3x. And now here, look at what's going to happen. We got a negative 2/3 times a negative 1/3 and also times a third. So negative 2/3 times negative 1/3 is positive 2/9 times another 1/3 is positive 2/27 e to the 3x plus c. And as always, we can check this answer by taking the derivative. We should get back to the original. So there's the antiderivative.